Hello, welcome, and this is College Algebra, and I'm going to talk to you in this video on the basic definition of sets. So this is like a review. So through the next few videos, we're going to go through the basically reviewing concepts for College Algebra. So start with sets. Okay, so here are some definitions. And so we start with basic definition. So what is a set? A set is a collection of objects. That's it. So it could be a set of cars, it could be a set of marbles, it could be a set of colors, it could be a group of political party affiliation. So it's just a collection of objects, and those objects can be defined accordingly. Elements, or what we call members of a set. Those are the objects that belong to a set. So if these objects have certain characteristics that the set requires, then all of the objects that have those characteristics are elements of that set. So if I say the set of eye colors, right? So then all of the different eye colors would be elements of the set. So you'd have brown, blue, hazel, green, whatever. Okay? And those would be the elements of the set. Okay? Set braces. These are what we use to bookend to represent a set. If we don't have these, then we don't have a set. We just have a collection of numbers. So for example, if I wanted to write the set of the numbers on a six-sided die, right? Then I could write the set as 1, 2, 3, 4, 5, 6 with braces around them. So that means this is a set. Okay? If I don't have the braces, then I'm not depicting a set. I'm not denoting a set. I'm just denoting a sequence of numbers. So be careful. It's important to use the braces to represent a set. Okay? Especially on a test or a quiz or homework, you want to make sure that you are saying what you want to say. Okay? So it's important to have the braces if you are representing a set. Okay? Now there are two other things as far as types of sets. There's infinite sets and there's finite sets. And obviously the name probably gives away. An infinite set has an infinite number of objects or elements in the set. Finite sets, as you would guess, have a finite number of elements. Okay? Now the natural numbers, we're going to do a lot with the natural numbers and we're going to build from there, but the natural numbers are the set of numbers that start with 1 and go on up there to infinity. So in this case here, notice I used my set braces and I use, the set of numbers. We also call these the counting numbers, by the way, because these are the numbers we naturally use to count things. 1, we don't start at 0, right? We don't start at -1. When we count, we start with 1. So we call these the natural numbers or the counting numbers. And so again, we use our set braces and we just put in 1, 2, 3, 4, and so on. Now the 3 dots here, these are called the ellipses or ellipsis. The ellipsis tells us that, in mathematics anyway, not in English or composition, but in mathematics, the ellipsis tells us that, hey, this pattern continues to infinity. Okay? In this case, it just says it just continues. Oh, excuse me. It continues in like fashion. Okay? Also, if you have ellipsis in the middle, for example, just for incidentally so you guys know, if I have, let's say, the numbers 1 through 100 and I write something like this, and again, I'm just going to, for example, if I want to write the numbers 1 to 100, I'm not going to write all the 100 digits. So I'm going to write 1. If I want to represent the set of 100 numbers, and I don't want to write all the numbers out, right? So if I want to represent the set of all numbers, all natural numbers from 1 to 100, I would write it like this. 1, 2, 3, like that. So in this case, the ellipsis means, hey, this continues in like fashion and then up to 100. Okay? So again, another way to write the sets. Okay? Again, just notation-wise. Okay. Set builder notation. So set builder notation is very important, especially later on when we start jumping into algebra. We're going to want to make sure we know how to write set builder notation. Okay? The way it works is, again, the set builder notation means, hey, instead of writing it this way, this is the list method. Okay? We can list out the numbers. That's the list method. Okay? But like I said earlier, you're going to have numbers that are going to be infinite. You're going to have infinite sets. Okay? So is there an easier, more concise way of writing or denoting a set? Yes, and it's set builder notation. And so what you do is you use the set braces to denote a set, and then in the set you're going to write the rule, the variable and the rule. Okay? Now what's the rule? The rule tells, hey, what are the characteristics in order to be an element in the set? Okay? So inside here, the way we read this is we say, okay, the set of all variables x, of all x, and this vertical line, and sometimes you'll see it as a colon, but it's either a vertical line or a colon, means such that the following must be true. Okay? So, which is the rule. So we say, I want this set of all objects x such that, and then the rule. Okay? So, what's an example of set builder notation that we could use? Okay. So let's say I want to represent let's say I want the set of all here we go. I want the set of all numbers that are less than 3. Let's do that. Well, if I want the set of all numbers that are less than 3, and let's call this set A. We usually use capital letters to denote sets. So let's say set A is the set of all natural numbers less than 3. Well, how would I write that in set builder notation? Well, I would write it this way. I want to say that, hey, the set of all x such that x is an element of the natural numbers, comma, x is less than 3. So what I'm saying here is, hey, I want A to be the set of all values x, all x, such that x is an element, that's what the symbol means, an element of the natural numbers. This is the symbol for the natural numbers. That's another way we can denote a set. Certain sets we can denote by bold-faced letters, so these are sets that have been determined in mathematics, so this is what we determine as the natural numbers. So we said all x such that x is a natural number and, the comma means and, x is also less than 3. And so this represents everything I want to know. So instead of writing it this way, just saying, hey, Oops. Can't make a mistake. Right? So there we go. Now, obviously, this would be the easier way of writing it, right? But I just wanted to show you what I mean, okay? But for infinite sets, we definitely would want to write set builder notation. So again, if I say, hey, I want all real numbers I want to represent all real numbers or all natural numbers less than 1,000 or between 50 and 1,000. So in that case I would say I want all x such that x is an element of the natural numbers and now I put the equal sign in there, the equals, because I said I want all numbers 50 to 100, right? I didn't say between. So this is going to be from 50 to 100, okay? And that's the way we would write it, okay? So instead of writing out 50, 51, 52, 53, boom, this represents the whole thing. That's it. Okay, next time we'll go further, but this is all I wanted to cover today, and I'll see you next time. Have a great day.